So, all right. So there's a boat ramp. It's at the edge of a lake, and 10 meters to the horizontal, and the trailer is 250 kilograms, and this guy's trying to pull it this way. So we can ignore friction, so there's no friction force like this. It's not there. So constant force that would be required to prevent the trailer from moving down the ramp. So if it's not moving down the ramp, then it either has to be not moving at all or moving up. But in this case, you can like tell from the question that it's asking when it's zero, like when F net is zero. It's asking for the minimum, like that's insinuated. It's asking for the lowest value of F. So if that's happening, F net equals zero. So F minus, so the weight force here is 250 G. So if we do the vector resolution, it's 250 G sine 10. That's the component of the weight force that's parallel to the plane, equals MA, but this is actually zero. So if you rearrange this, it's F is just equal to sine 10. Sorry. Oops, got rid of the F. So then F is just, if you put that into your CAS, 425 newtons. So if the man exerts a force of 200 newtons on the rope, find the acceleration on the trailer. So this time they give you what F is, and we can just do F net again. So 200 minus 250 G sine 10 equals MA. Well, M is actually 250, so 250A. And you can just put this into your CAS and solve for A. It's 0.9017, but it's asking for 3 decimal places, so we round it to 0.902. So use your answer from part B to find the speed of the trailer corrected 2 decimal places after it's moved 30 meters down. So the thing to realize here is it's a constant force. F is a constant force. So if it's a constant force, then acceleration is constant. So we can use our constant acceleration formulas. So we know A is 0.902. They're telling us specifically to use this value, so we don't have to worry about the extra decimals this time. Minus 2, and it's moving from rest, so U is ms minus 1. We're trying to find V. Oh, we're trying to find S, but we can just get rid of the direction if we find V. And S is 30 because it's moved to 30 meters down the ramp. So the thing we don't have is T, so we're looking for the equation that doesn't have T, and that's V squared equals U squared plus 2AS. So U is 0, so V is just 2AS. If you sub these values in, V is 3.76 if I'm reading my handwriting correctly. So show the differential equation can be written as this. So for this one, so the kind of the trick or what you have to realize is that if you, so X is displacement. So dx dt is V. So d squared x dt is A. So you could rewrite this as A equals 1.47 minus dx dt is V, so it's 7 minus V. And now we have to convert this to here. So you can see we have this term, and if we're going to convert A to look something like this, we only know that A is V times dV dx. So we could do 1.4, oh, sorry. So we write A in terms of this. So V times dV dx equals 1.47 minus V. And you can see the 1.4 is here. So, oh, sorry. The first thing you see is that dx and dV have flipped. So we're going to flip the whole thing. So 1V times dx dV equals 1 on 1.47 minus V. And then you can see that the 1.4 is here and it's a fraction here. So you're going to multiply that over there. So 1.4 times 1 on v times dx dv equals 1 on 7 minus v. And then we don't have this term on the left-hand side, you can see here. So we're going to multiply that to the other side. V on 7 minus v. And then you can see it doesn't look the same here, but you can kind of tell that what they've done is simplified the fraction. So to do that, we write the denominator on the numerator and we add or minus stuff to remake the original numerator. So dx dv equals -1 plus 7 minus v, and that's what we needed. So hence show by integration that 1.4x is this. So we take this that we just found, 1.4 dx dv equals -1 plus 7 minus v, and we want x on this side, so we can multiply the dv onto the other side. Dx equals -1 plus 7 minus v dv. So this is just 1.4x equals -x, and we know this is the log, and plus c, and then you can sub 0, 0 because it says sinks vertically from rest. So like when x is 0, so displacement from like the like when it's here and it's sinking into the water, so displacement from here, x is 0, and v is also 0 because it's from rest. So that's why it's from 0, 0. So 0 equals -0 minus 7 ln 7 plus c. So c is just ln 7, and if you sub that back into here, it's -x minus 7 ln 7 minus v. Sorry, 7 minus v plus 7 ln 7. You can get rid of the mod and make it brackets for this question like here, because v is going to be negative because it's going down. Yeah. So when the trailer has sunk to a depth of d meters, it's descending at a rate of 5 meters. So find d find d. So we have our equation, we already have it from the previous question. 1.4x equals -v -7 ln 7 minus v plus 7 ln 7. So at this place that they're talking about, x is d and v is 5. So you can just put 1.5d equals -5, is this v? Sorry, I wrote x. V, so -5 minus 7, 2 plus 7, 7. And you could just solve for d on your CAS. And d is 2.7, if that's what that says. So now it's just asking, write definite integral for time it takes for the trailer to sink down to a depth of d meters and evaluate this integral. So at d meters, v equals 5. So from like the where is it here? We know that a is 1.57 minus v. And that's important because now we're bringing in time. So the only way of bringing in time to this would be if we rewrite one of these things as time, but it would be like we can't convert this to time because we don't know how to do that. So if we go back, the only thing we can convert to time is from here using this relation. So, sorry, not that one. Like, we can use a equals dv on dt. So that's why we use that one and not the other equations. So from here, we use dv dt equals 1.47 minus t. So if you rearrange this, 7 minus v dv equals 1.4t negative ln 7 minus v plus c equals 1.4t, and then we can sub 0, 0 again because we know it starts from rest. Sub 0, 0, so negative 7 ln 7 plus c equals 0. C is ln 7. So 1.4t is, if we sub this back in here, we can see it's going to be ln 7 on 7 minus v. So t is 1.4 ln 7 on 7 minus v. So we want when v is 5, and we know when v is 0, t is 0. So we use that like integral trick, I guess. So if we integrate 5 on 0 t dt to 5 on 0 1.4 ln 7 minus v dv, because like we know the initial conditions, but we don't know the final condition. You can do, so t5, which is what we want, minus t0 equals 5 to 0 1.4 ln 7 minus v dv. This is 0, so you can just put this into your cas, and you get t at v equals 5 is 0.9 seconds. I think the answers say you can just do t is 5 to 0 101.57 minus v dv, which is the same thing. I just because essentially what they're doing is integrating it as t. So like they just did this step without expanding it, which is probably much easier. But for 3 marks, I thought we would have to expand it and find the equation. But it doesn't really matter because, especially with the c value, because it would just cancel that anyway. So yeah, that's question 5.